So our lesson today is antiderivatives. Hey guys, I haven't seen you in like a week. Oh, like talked to you in a week. I haven't seen you in like 5, which is just crazy snakes. I'm going to plan on doing Google Hangouts Meet again so that we can chat and talk if you want to. If you don't want to, that's completely fine as usual. I'll plan it for this week and I'll let you know in Google Classroom. But I am missing you guys, and I actually miss all of the hilarious talk, and I miss Lucas actually not being on task, and I miss everyone being hilarious. I miss all of that. All I get to do now is boring podcasts with no funny. So I really do miss you guys, and I want you guys to know that. So I'm going to do, like I said, a Google Hangouts Meet, and hopefully we can talk this week and see how your Easter break was. All right, antiderivatives. So this is the day where we start learning how to undo derivatives, okay? When we did power rule with derivatives, we would take the exponent. So say we had y equals 2x cubed, and we did the derivative of it, y prime. We would take the power, drop it in front, multiply it, and then reduce the exponent by 1, right? That's what we always did. So we got 6x squared. So to undo it, what we're going to do is we're going to raise the exponent by 1, and instead of multiplying by that number, we're going to divide by it, okay? Because what did we do? We took the exponent, dropped it in front, and decreased the exponent by 1. So now we're going to raise the exponent by 1 and divide by that number because we multiplied before, okay? So that's just a glimpse into what we're going to do. So we have learned in the past units how to find derivatives of functions. For example, if we wanted to find d over dx of 3x squared, we want to find the derivative of it, we would take our exponent, drop it in front. So we go 3 times 3x, and then we drop it by 1, 3x squared. So we get 9x squared, right? Now, if we had 3x cubed plus 7, and we took the derivative of that, we would go drop our 3 in front, 3 times 3x, drop it by 1 squared, and then the derivative of 7 is nothing. So I would go plus 0 at the back, right? So I would get 9x squared. Whoopsies. Drop my hand down. 9x squared. So if you look at the previous answer, when it's 3x cubed, my derivative is 9x squared. When it's 3x cubed plus 7, my derivative is 9x squared. When it's 3x cubed minus pi, I'm going to get 9x squared, because pi is just a number, 3.14159, and it keeps going. And when you take the derivative of a number, you get 0, right? So that's going to be our issue when we do antiderivatives, when we undo these derivatives. Every single term we found the derivative of, we have remnants of it. So for example, if I take 9x squared, that's a remnant of 3x cubed before, right? But where are the remnants? Where are the leftovers to show me what the heck that constant was? There, it isn't. So every time we do an antiderivative, we're going to have to put a plus c at the back, a letter c, a constant, because we don't know what that constant is. There's no numbers left behind. So here I have 9x squared for 3x cubed. I have 9x squared as the derivative for 3x cubed plus 7, and I have 9x squared for the derivative of 3x cubed minus pi. So they all look the exact same. So if I go to undo them, how do I know what that constant was? Or if there even was a constant, because this one there wasn't. So we're going to put a plus c at the back for the constants. And the only way we can find out what the constant is if they give us a point off the original. If they don't, we have to leave just a plus c at the back, and it stays that way until we figure it out. So here it is. The biggest issue when determining the antiderivative of a derivative is you have no remnants of the constant. So you have to label it a c unless the question gives you a point on the original equation to solve for the value c. So this is important right here. When asked to find the antiderivative of a function, you can use integral symbol, this little squiggle. It's on the front. Oh, it was on the front of the old books, but it looks like this. That means determine the antiderivative of this. So whatever's beside the integral, if it's beside an integral symbol, it's the derivative, okay? That's what that integral symbol gives you. So for example, determine the value of the integral of 9x squared dx 9x squared is the derivative, and dx tells me I took it with respect to x. It's asking me to determine the antiderivative of 9x squared. The integral symbol and the expression followed by dx tells you you are given a derivative. Okay? Just as the first derivative is used to find the tangent slope or rate of change, that's what we did when we found the first derivative, right? It gave us a tangent slope or rate of change. The integral, or the antiderivative, gives us the area under a curve. So after we learn how to do antiderivatives, we're going to be finding areas under a curve. We're going to be finding volumes of revolution, and those all come from antiderivatives. Okay? So if I gave you the curve x squared, which is this graph like this, and I wanted the area under that curve from here to this area here, I would actually find the antiderivative of x squared. Okay? And they're going to ask between certain x values and such like that. So that's to come. Now, here's the table for integrals. So if I'm given c of f of x dx, I can take the c out and then just find the antiderivative of f of x. Okay? If I have k, which is just like a number, like 7 or whatever, I would get kx plus c. And it keeps going on and on and on. So it gives you the list of all the derivatives that we're going to use. And we will deal with those as we go along. You'll see them. So this is a little helpful table that you can come back to. All right. Determine the antiderivative of the number 0. Okay? The number 0, oh my goodness, I keep doing that. The number 0 actually hasn't a variable. It's a variable x to the 0. Okay? When we found the derivative, what we did was we took the exponent, we dropped it in front, right? And then we reduced our exponent by 1. So now what we're going to do the antiderivative is we're going to raise our exponent by 1 and divide by it in front. So before we lowered it and multiplied by it, now we're going to raise it and divide by it to get it back to where it was. Okay, so when we raise that exponent by 1, so f of x just tells me the derivative because it's asking me for the antiderivative. How do I show what the original is when it uses an f of x, not an f prime of x? Well, what we do is we use a capital F. That shows us the original. That's how they show that they're finding the original. Okay, so we have the number 0 in front. Now what we're going to do is we're going to take x, we're going to raise it by 1. So it's at a 0, it's going to be to 1, and then we're going to divide by that 1. Okay? So now we literally have 0 times x, which is still 0. Now what we have to remember to do at the back always, though, is we have to add that constant. Because we don't know if there was a number 7 at the back before they took the derivative, or a 6, or a pi, or a half. Any of those things that could be constants at the back, those numbers, when we take the derivative of them, they go away. So we always have to put plus c at the back. So I have 0 plus c, which is just c. So this is telling me I'm working backwards, right? We can always check these. The great thing is if you get your antiderivative right, you can take the derivative of it and see if you get the original. So if I take the derivative of a constant being like the number 7, 24, 83, a half, pi, e, if I take the derivative of those, I get 0. So that makes sense. If I'm left with a constant at the end, the derivative is 0. So I know I'm right. And I can move on. Okay. If I do f of theta equals negative sine theta, that's the derivative. I need to find the original. So f of theta. So I know to get the derivative of sine, I'm going to use cos. So cos theta, the derivative of cos theta, equals negative sine theta, right? Because coses are always negative. So if the derivative of cos theta is negative sine theta, then I know if I have given the antiderivative, if I'm given the derivative of negative sine theta, the antiderivative, what was it before? It was cos theta. So I'm going to go cos theta, and I'm going to add a plus c at the back, that constant, and I can't forget to add that. So every single time you do an antiderivative, there should be a plus c at the back. And to be honest, that's the thing that everyone forgets, to put that plus c. But we don't know what the constant was because there's no remnants of it showing us it. Okay, let's look at c. c is f of x equals x to the half. So that's the derivative. Okay, so we're trying to find the original, f of x. So this is just a power rule. So we got the derivative was x to the half. So what did I tell you do? You rewrite it. Then I said we increase the exponent by 1. So we decreased it to do the derivative. To do the antiderivative, we're going to add 1 to it. So if I go a half plus 1, that's the same as saying a half plus 2 over 2, right? Because we need to have a common base in order to add fractions. So that's 3 over 2. So if I add 1 to a half, I get 3 over 2. So I'm going to now get an exponent of 3 over 2. And then what did I tell you to do? I told you to divide by that. Well, when I divide by 3 over 2, it's the same as multiplying by 2 over 3, right? So if I have 1 divided by 3 over 2, I'm actually going 1 times 2 over 3. So I get 2 over 3. And what do I have to do at the back? I have to add c, always, because I don't know if there was a constant before. So now I'm going to get equal to 2 over 3, because 1 divided by 3 over 2 is 2 over 3, x to the 3 over 2 plus c. And I'm going to check it. I'm going to check it down here. So I'm going to find the derivative of my answer. So my answer is 2/3 x cubed. This is just for me verifying to prove to me I did it right. So to find the derivative, I take the exponent, drop it in front. So I'm going to get 3 halves times 2/3 x. I take my exponent and drop it by 1, so 3 halves minus 1 is a half, plus c. So what do I get? These cancel, x to the half. And then the derivative of a constant is just 0. So it's x to the half. And then I check and see if my question was that. Look, my question is x to the half, so I know I did it right. So the great thing about antiderivatives is you can take the derivative of them and see if you get the question. And if you get the question, then you did the whole thing right. Okay. Go to D. Okay, D is a power rule one again. So I'm going to go f of x, which means I'm finding the original. So what do? I rewrite my variable. Then and my question. Okay. So I rewrite my variable, the whole thing, but the variable is going to have an exponent where it increases by 1. So my exponent's going to become 3 now, and I'm going to divide by that exponent. And then for the next one, I rewrite it, minus 6x. It's normally to the 1, right? So it's now going to increase by 1 because it decreased to get to be a derivative. So it's going to become a 2, and then I'm going to divide by that exponent. And then what I have to remember to do is put a plus c, and you guys will all forget that. So please remember to write that constant because we don't know what the constant was. So now we're going to get f of x equals, the 3's cancel, x cubed minus 3x squared plus c. And we're done. And this one we can do the derivative quickly. So x cubed would be, the derivative would be 3x squared, boom. Negative 6x squared would be negative 6x, and the constant would become 0. So I know I'm right. Okay. This one, once again, is another power rule, but it's a quite intense one, so we're going to practice it. So we go f of x equals, we rewrite it without the exponent, so negative 2x. If I take 1/3, I'm now going to have to add 1. So I'm going to add 3 over 3, because that's like adding 1. So I now get 4 over 3, right? So my new exponent is going to be 4 over 3. And then I told you divide by that. Then I get plus 1/4 x. And I have to change my exponent because I have to add 1 to it. So I'm going to go a half plus 1, so plus 2 over 2. And I get 3 over 2. So that's my new exponent. And then I'm going to divide by it. And then I have to put a plus c at the back. So what does that mean? When I divide by a fraction, it's like multiplying by its reciprocal, right? So I'm going to get 3 over 4 times negative 2 x to the 4/3 plus, instead of dividing by 3 over 2, I'm going to multiply by 2 over 3 times 1/4 x to the 3/2 plus c. And so I'm going to get negative 6 over 4, which reduces to negative 3 over 2 x to the 4/3 and then I'm going to get 2 over 12, which reduces to 1 over 6 x to the 3/2 plus 6. And then once again, I can check that and see if I take the derivative of that, do I get this? And I will. Okay. Determine the value of y when dy over dx equals ex plus 6x squared minus cos x. So I have to undo it. So dy over dx is going to become y, because that's the original, right? And if I took the derivative of y, it was dy over dx. What's the derivative of e to the x? E to the x. So what's the antiderivative of e to the x? E to the x. Okay. And then 6x squared is 6 over x squared, is the same as saying 6x to the negative 2. So I'm going to rewrite it. 6x. But what do? I raise my exponent by 1. So it's at negative 2. It's now going to be at negative 1. Because if I add 1 to negative 2, I get negative 1. And then I'm going to divide by that. And now I have to take the derivative of negative cos. Well, the derivative of sine is what's going to get you that. So the derivative of sine x actually gets you cos x. But I need negative cos x. So the antiderivative of cos x is sine x, sorry. The antiderivative of negative cos x then would actually be negative sine x. So I'm going to get a minus sine x back here. And then what do I have to not forget to do? Plus c. And now I have to rewrite it. So I'm going to get y equals e to the x minus 6x to the negative 1 minus sine x plus c. And some of you will really want to write that x to the negative 1 as positive, so you can rewrite it as e to the x minus 6 over x to the 1 technically, or just x, minus sine x plus c. And remember, you can take the derivative of this and see if you get the original. That's a 6. It does not look like a 6. I'm going to erase it. Looks a little better. Okay, dy over dx means I have the derivative of 5x squared. So I'm going to go y equals, I'm going to rewrite the 5x. I'm going to increase my exponent by 1. So I'm going to get 3, and then I'm going to divide by it. Then I'm going to get plus 2, and then it would technically be x to the 0, right, when it doesn't have a variable. So this is going to be x still, but instead of x to the 0, come on, pen. Instead of x to the 0, it's going to be x to the 1. And then I'm going to divide by that 1. And what can't I forget? The plus c. And I bet you throughout this notes, at some point in time, I'm going to forget that plus c, because it's the easiest thing to forget. And so now I'm going to get 5 over 3 x cubed plus 2x plus c. Boom. And remember, I can take the 3, I can multiply it in front, then I get 5x squared plus 2, and I can check to make sure I get back to my original. So I can always check these. Okay, so for all of these, I had to just put a c because I couldn't do anything better. I couldn't find out what that c was. But in some cases, they can give you, like example 3, solve the differential equation dy over dx equals x squared plus 2x plus 1. So they want you to find the original with the boundary condition when x equals 3 and y equals negative 1, and then verify your equation. So they gave us a derivative, dy over dx equals x squared plus 2x plus 1. And they gave us a point off the original, which is at 3 and negative 1. Okay? So the first thing we're going to have to do is find the derivative of this. So we're going to get y equals x, technically 1x. Now what am I going to do? Like I do every time, I'm going to increase that by 1. So 2 is going to become a 3, and then I'm going to divide by 3. And then I'm going to go plus 2x and it was a 1, and this was x to the 0. I'm just going to put that just so we know. It's x to the 1. It's now going to become x to the 2, and then I'm going to divide by 2. And then I'm going to get plus 1x, but instead of a 0, it's now going to increase by 1. So x to the 1, divide by 1, and then I'm going to get a plus c. So I'm going to get y equals 1/3 x cubed, the 2's cancel, plus x squared, the 1's cancel, plus 1 plus c. And normally, 1x, sorry, I need to erase that. Plus 1x plus c. And normally we'd be done, but they actually gave us a point off this original equation. This is my original xy, not my derivative xy. This is my original xy. And so if I'm missing a variable, we know this before, if I plug in xy, I can solve for that c. So if they give me a point off the original, I can actually find out what the heck c was. So the only way you can actually find out what the constant was is if they give you a point off the original. If they don't, plus c is in your answer and it stays that way. So let's find out what c would be. So I'm going to say y equals, I'm just going to rewrite the equation, 1/3 x cubed plus x squared plus 1x plus c. Now instead of y, I'm going to put -1 equals 1/3 3 cubed plus 3 squared plus 1 times 3 plus c. So I get -1 equals 1/3 times 27, which is actually 9, plus 9 plus 3 plus c, which gets me -1 equals 9 plus 9 plus 3 plus c. So I get -1 minus, this is technically 9 plus 9 is 18 plus 3 is 27, so I'm 21, sorry, so I'm going to move the 21 over, I'm going to minus it, equals c. So c equals -22. So now I know what the heck c actually was, because they gave me a point. So now I can rewrite the equation with the c. So I get y equals 1/3 x cubed plus x squared plus x minus 22. And now I actually don't have the c there because I figured out what c was. Boom. So you can actually figure out c, but they have to give you a point off the original. Okay? Another thing they could do, they could give you the second derivative. So solve the differential equation, d2y dx squared equals 12x squared. So now they want the original, so I'm going to actually have to do the derivative, work backwards twice. With the boundary conditions, x equals 0 and 1, so they gave me a point off the original, 0 and 1, and 3 and 8. So those are my original points, my two xy's. And I need two xy's because I'm going to end up with two c's. A c, and I guess I could label the other one a d instead of a c, because I have to do antiderivative twice. So we're going to see how this is going to work. So I'm going to go d2y over dx squared equals 12x squared. So then I'm going to go dy over dx because I'm finding the first derivative. And what do I do when I do the antiderivative? Okay, I rewrite it. And I'm going to increase my exponent by 1. So 2 is going to become a 3, and I'm going to divide by that. And then I'm going to put a plus c at the back. So I know dy over dx equals 4x cubed plus c. So I have dy over dx equals 4x cubed plus c. And now I need to find the antiderivative of that. C is actually x to the 0, right? Because when there's no variable, it's x to the 0. And normally I wouldn't put x to the 0, but I have to find the derivative of that. So I'm going to take and find the derivative of that. So dy over dx, the antiderivative of that, is y. Then I'm going to get 4x And the 3 is going to become a 4, because I raise it by 1, divide by 4. And you guys are going to catch yourself subtracting 1 all the time because you've done derivatives for so long. But antiderivatives, you have to add 1. Okay, and I put the 0 because I need to keep going. So I'm going to get cx, but now instead of it to the 0, it's going to be to the 1, and I'm going to divide by 1. And then I need to put a new constant at the back. And instead of c, because I already have c, I'm going to write d. Okay, so y equals 4, nope, the 4's cancel. That's my mistake. I just made that go away. Oops. Leaves back. So the 4's cancel. And I'm left with x to the 4 plus cx plus d. And now I'm missing 2 variables. And when I'm missing 2 variables, I need to have 2 points. So I'm going to use the 0, 1 first. Always use the one with either x as 0 or y as 0. X as 0 would be preferable. So I'm going to go 1 equals, so I'm using this coordinate here, 0 and 1. 1 equals 0 to the 4. Oh my goodness, that's a disaster. 0 to the 4 plus c times 0 plus d. So this cancels. This cancels. So I get d equals 1. So now I know what d is, so I can put that in. So now I'm going to get, instead of this, I'm going to get y equals x to the 4 plus cx plus 1, because now I found out what d is. And I use my other coordinate. My other coordinate is 3, 8. So that's x, y, and I'm going to use those to solve for c. So I'm going to get 8 equals 3 to the 4 plus c times 3 plus 1. So 8 equals 81 plus 3c plus 1. So I subtract 82 over. Nope, didn't mean to do that. I'm just going to back up so it doesn't look like that. Okay. Those canceled. So 8 minus 82 is negative 74 equals 3c. Divide by 3. And c equals negative 74 over 3. Which looks messy and bothersome. I'm really sick of my kindergarten handwriting here. 74 over 3. That's not much better. And now I can rewrite the equation with the c in it. So I'm going to get y equals x to the 4 minus 74 over 3x plus 1. And like I said before, you can find the second derivative of this now, and it should be 12x squared. And if it is, then you're good. Okay. Now, we're going to go over rectilinear motions. So, remember that the derivative of s being distance, so ds over dt, the derivative of distance formula is velocity, the derivative of velocity formula is acceleration, and the second derivative of the distance is acceleration. So now, if I give you acceleration and want distance, you're going to have to do the antiderivative twice. If I give you velocity and want distance, you're going to have to do the antiderivative once. If I give you velocity and want distance, you have to do the antiderivative once. So it just depends on what I gave you. So find the distance s of an object from its origin at time t if this is the acceleration. Acceleration is 8t minus 3. And sometimes the acceleration is just a number, and that's fine. So we know that the acceleration, a of t, equals 8t minus 3. Okay? And it wants us to find the distance. So we're going to actually have to do the antiderivative twice to get back to distance from acceleration. Now, throughout that, we're going to get two c values, right? So if they give me a point off the velocity, I can find the c for that one. If they give me the point off the distance, I can find the c for that one. And they did. So they gave us that the initial velocity is 4. So off the velocity formula, they gave me a point at 0, 4. And then off the distance formula, so the S formula, I'm going to call it distance, or S, I guess, equals S. They gave me a point at 0, 1. And those are going to be helpful to get my C's along the way. Okay, so if I take the antiderivative of acceleration, I will get velocity. So what do? I'm going to go v of t, because now I'm going to get velocity. I'm going to rewrite this. Oh, this is 8t minus 3t to the 0, technically, right? So I have to put that. So what I'm going to do, I'm going to rewrite it. 8t. I'm going to raise it by 1 exponent, so it's going to be t to the 1. And I'm going to divide by 1. Then I'm going to get minus 3t. And instead of 0, it's going to be to the 1, because I have to raise it to 1. Divide. Oh my goodness. Erase. Okay, this is t to the 1, so it's going to be t to the 2. You're probably all freaking out right now. Sorry, it's a 2, because you have to raise it by 1 and divide by it. Then I get minus 3t. It's going to be to the 1, divide by 1, and I have to put the plus c. So now v of t equals 4t squared minus 3t plus c. But I don't know what that c is, but they gave me a coordinate off of the velocity formula, so I can plug that in for v and for t, and I can solve for c. So that's what I'm going to do next. So I'm going to go 4, because that's my v, or my y, equals 4 times 0 squared minus 3 times 0 plus c. And so I'm going to get 4 equals c, because the rest is going to cancel. So now my velocity formula is actually 4t squared minus 3t plus 4. Okay? Now I have to find the antiderivative of that to get the distance formula, to get dt or st. In this case, they labeled it as s for distance. So to get st, I have to find the antiderivative of this. So what am I going to do? I'm going to go 4t. It's now going to be to the 3. Divide by 3. Minus 3t to the 1 is what it is, but it's now going to be to the 2. Divide by 2. This is technically t to the 0. Ooh, that's a mess. That's actually what that is. So this is going to be t to... I have an eraser out. Good job, Crystal. T to the 0. Oh my gosh. It's getting worse. Oh my goodness. Oh my goodness. 4t to the 0 is going to become plus 4t to the 1 divided by 1 plus c. And now I need to find out what that c is by using 0, 1, because that's the distance formula 1. So I'm going to go away. I'm going to go 1 equals 4 over 3 times 0 cubed minus, I'm going to do it up top because I'm getting squishy. So I'm just going to do this. Oh my goodness. I'm going to do it here. So I'm going to get 4 over 3. I'm going to get 1 first. 1 equals 4 over 3. Oh my gosh, it's getting so messy. 0 cubed. My writing's looking like Jackson's right now. It's so messy. Just kidding. His writing's beautiful. Minus 3 over 2. 0 squared. Plus 4 times 0 plus c. These are all going to cancel because they're going to be times 0. So c equals 1. And then I can just write the distance formula. So s of t equals 4 over 3 t cubed minus 3 over 2 t squared plus 4 t plus 1. That's the answer. All right. Then the last ones you have to do. So indefinite integrals. So I just wanted to show you this because d over dx of f of x equals little f of x. So what I told you is they can label the derivative of f of x, and then you would label the antiderivative or the original equation as capital F of x. Or what they can do is they can just do little integral symbol, f of x dx. And when you have the integral symbol with the little dx, that means they gave you the derivative, and they want you to find the antiderivative. Okay, so it's another way they could write it. It's just different ways to write the same thing. Okay, so they want us to determine antiderivative of x squared plus 1 dx. So we're literally just finding the antiderivative of that. So we're going to go equals. And what do? I rewrite it. X, raise it to the exponent 1 higher, cubed, and then divide by that 3. And then this is just 1x to the 0. So now it's going to become plus 1x. And instead of to the 0, it's going to be to the 1, divide by 1, plus c. We can't forget that plus c. You will forget the plus c. Don't forget the plus c. So we're going to get 1/3 x cubed plus x plus c. Boom. And we're done it. So we don't need to write it as equal to anything because it's just this integral symbol means this is the derivative of it, and it equals this as the antiderivative. Now they gave us the derivative of x to the 4. So to find the antiderivative of that, we're going to rewrite it. X, we're going to raise it to 1 power higher, 5. We're going to divide by 5. And then we're going to have to add a plus c at the back because we don't know what the constant was because there's no remnants of it. So we're left with 1/5 x to the 5 plus c. That's your antiderivative. And once again, you can check those by finding the derivative of them. Okay, whenever you have a square root, what did I tell you to do the whole year? Rewrite it to the half. So it's x to the half dx. So we're going to end up getting 1 x, raise a half, add 1 to it. So if I take a half plus 1, I get 3/2. And then I'm going to divide by 3/2 plus c. When I divide by 3/2, it's the same as multiplying by 2/3. So I'm going to get 2/3 times 1 x to the 3/2 plus c. 2/3 times 1 is just 2/3 x to the 3/2 plus c. Okay, D. If it looks like it's a quotient rule or something, we don't reverse quotient rule things. So the best thing you could do first off is see if you can split it up and get it to not look so messy. So remember, I told you guys before that you're really good at putting together fractions, but you're not great at pulling apart fractions. So this is the same as writing sine x over cos x times cos x. Dx. So instead of writing it all together, we could write it as partial fractions. So I'm still writing the integral symbol because I haven't taken the antiderivative of anything. So what I can do is I can go sine x over cos x times 1 over cos x. And if you don't believe me, reverse multiply them. So multiply them back and see if you get what we had. See if you get this previous step. So sine x times 1 is sine x. Cos x times cos x is cos squared x. So we do get it back. So you can split them up. Now, why would I do that? Okay, still have the antiderivative sign because I haven't taken it, the integral. Sine x over cos x is tan x. And 1 over cos x is secant x. Now, why the heck would I do that? Because the derivative, nope, did the integral symbol, bad on me. The derivative of secant x, what is it? The derivative of secant x is secant x tan x. And what do I have right now? I have the derivative tan x secant x, which is the same as secant x tan x. So what would the antiderivative of that be? Secant x. So the answer to this is secant x. You drop the integral symbol off because the moment you find the antiderivative, the integral symbol goes away. And what do you have to remember to do? Plus c. And I told you, everyone forgets that. I forget it too. Did not mean to do that. Don't know how I did that. Okay. 2 more left. Let's do the antiderivative of this. So we rewrite it. 2x add 1 to 1/3. So you get 4/3. Then we divide by 4/3. Goodness, the writing is terrible. Plus 5x, add 1 to it, and you get a 0. Okay, the problem here is you can't have x to the 0. So this is actually the same as writing 5 times 1 over x, right? Now let's go back. What derivative did we take that got us 1 over x as an answer? If I took the derivative of ln x, what was the answer to that? The derivative of ln x, anything beside a ln, you rewrite on the bottom, and then the derivative of it on top. So actually, whenever you get x to the negative 1, the antiderivative of x to the negative 1 is ln x. So I'm not going to get 5x to the 0 divided by 0 because I can't divide by 0. If you're catching yourself doing this, be like, wait, I can't divide by 0. What did she tell me to do? Well, instead of writing this, what you actually write is 5, the 5 stays, and the derivative, or the antiderivative of x to the negative 1, x to the negative 1 being 1 over x, is actually ln x. So the antiderivative of 5, x to the negative 1, or 5, 1 over x, is actually 5 ln absolute value of x. And you have to put the absolute value of x because we're not sure what it was before. Okay, so whenever you get x to the negative 1 and you raise it x to the 0 divided by 0, be like, wait a second, I can't do that. What is it? Oh, right. X to the negative 1, the antiderivative of that is ln x. And then I get a plus c at the back. So I'm going to get the 4/3 is going to become 3/4 because it flips, times 2 over 1, x to the 4 over 3, plus 5 ln x, ln absolute value of x, plus c. And so I'm going to get 6 over 4, or 3 over 2, x to the 4/3, plus 5 ln x, absolute value of x, plus c. Done. And then the last one, I'm going to rewrite it as a negative exponent. So I'm going to go 12 x to the negative 5, and I keep the integral symbol because I haven't done the antiderivative yet, plus this would be x to the half on the bottom, so it's going to be x to the negative 1/2 dx. And now I can do the antiderivative of it. So I'm going to get 12x, if I add 1 to negative 5, I actually get negative 4, divide by negative 4, plus x to the negative 1/2 is actually, add 1 to that, it's positive 1/2, and I'm going to divide by positive 1/2, and I'm going to put a plus c. So I'm going to get negative 3x to the negative 4, plus, instead of dividing by 1/2, I'm going to multiply by 2 over 1, x to the 1/2 plus c. And it would be okay to keep it as this answer, but what some people will do is they don't like the negative exponent, so they're going to put x to the 4 on the bottom, plus 2 x to the 1/2. Some people will write as square root x because they like that better, plus c, but it's perfectly fine this way. That is the end of antiderivatives. It was long, I know it is, but your next lesson, which is substitution rule, is much shorter, so they'll balance each other out. I hope you guys have a great day. I really, really miss you guys. Hopefully we can talk this week. See you later.